I have a...
Yes.
So, introduction of Coulombic interaction should increase attraction between electron and hole.
Correct.
So they form a bound state.
Correct.
Do you see that they come closer or stay at the same place? Do you see any signatures of formation of a bound state?
Not necessarily a bound state. We see that they become highly delocalized, and I would attribute that to, if you look at the nuclear potential energy surface, the electron starts at a much higher spot, and when you have high Coulombic interaction, you gain a lot of kinetic energy as they come close. So they come close, and then the electron just whizzes by, and it doesn't get as much trapped in the bigger potential well.
So could you again clarify? It's hard to see really these very thin lines, but you have two packets.
Yes.
Is it one for electron, one for hole?
Yes. So the one, this blue one here, this is the electron. The red is the hole.
So and they never really come together, right? They never really kind of combine together.
Correct. But at the end of the simulation, they become very delocalized, and you would assume that if they become very delocalized, all spread out through the system, because this is a periodic system, then they would have very high probability to be combined, if that makes sense. And another side note, our excited and ground state potentials were virtually identical. So that's why we stored our electron separated from our hole. If our excited and ground state differed dramatically, then you could theoretically start both of them at the same spot at the right after excitation and see how they...
But your potential, again, this complicated form of potential, as I understand, you're putting your electron on one ligand and your hole on the other ligand, right? This is kind of, initially you excite the charge transfer state.
So we put our electron on the
side.
ion, the hole is on the ruthenium.
But is it because this is a low stick state? Like any reason for changing it? I mean, any reason for why this parameters were used?
We know experimentally that this system can split the photoexcited electron hole pair, but through our ab initio calculations, the potentials were the same. And since this is a term project and we only had a few months to figure it out,
yeah,
we couldn't.
But if you, as you already said, like if you start with putting your electron and hole pretty much on the same spot, right?
Correct.
Would it still be able to kind of split into the, like, in other words, would your Coulomb interaction not be large enough comparing to your kinetic energy, so it still will go electron to one side, hole to the other?
We don't vary the momentum. The momentum's zero in our case.
You mean you're not giving the initial energy to your electron and to your hole?
Correct. We just say that they're excited straight, and then they go from there. Because my understanding is photoexcitation does not give momentum, it just goes from one ground state to the other ground state. But that phase would mean that there's momentum given. So this project is more looking at, can we put in the Coulombic and see how it works.
More, is it satisfactory?
Well, what I don't understand is saying having your wave packet cannot have kinetic energy zero, because then your momentum is completely undeveloped, unfound, right?
There could be in average.
It should be some range at least, right?
There could be in average. Expectation value of momentum can be zero.
Right, so you still have some distribution of your momentums, right?
Yes.
So it's not like really getting everything
but they
to
have
zero.
Opposite signs, so that in average it is zero.
They contribute to the zero average momentum. Okay, so you're saying it's really average zero momentum of your wave packet. Okay.
More questions? I have one.
Yes.
What if you follow the procedure by Jabet and contribute nuclear degrees of freedom to your system? Would it make your recombination rates quicker or slower?
I would say slower.
Yes, very good. Are there any questions, additional questions to Levi? If no, let's thank him once again. And it was a lot of effort.